proper ECDIS setting in navigational waters. Industry stakeholders have discussed a lot about the pros and cons of paperless navigation, concluding the ECDIS does have an edge over the traditional paper chart navigation. However, the question of navigating officer remains the same. Can they steer the vessel following a pre-scheduled passage plan within the safety margins that they set, from berth to berth, avoiding ground? At this point, it is worth to mention the passage plan main purpose, which is to use the available navigation waters for the intended voyage to the vessel could safely conduct the voyage. The navigation water can be mainly affected by the water depth, which is indicated both on paper charts and ENCs, especially the depth measurement as indicated is the result of a relevant depth survey which varies in age and quality depending on the measurement techniques and the available technology. Because priority for surviving is given to the major shipping routes, each navigator sailing into unfamiliar waters away from these routes should be able to interpret the various quality indicators that are or should be indicated on every chart. This is why many guides are available with the best practices of navigation for commercial vessel and crashing yaks that help mariners to decide on how much confidence they should show on the market depths. However, a mariner should be always wary of any chart that does not feature these indicators, irrespective or whether it is traditional paper chart or an ENC. ECDIS display versus traditional paper charts. On the traditional paper charts, the reliability diagram or zone of confidence diagram indicate the depth accuracy based on survey. Navigators should carefully check the areas that they have chosen to sail, find the relevant indication on diagram, and apply additional measures or safety features to protect the vessel from grounding. On ENCs, the same policy is followed with the exemption of the indication of accuracy, which is well spread and marked on the chart with CATZOCs, or categories of zone of confidence. The typical marks of A1, A2, B, C have now been replaced by symbol which indicates the accuracy of depth. This indication is subject to on or off selection by the navigator. Therefore, for an unfamiliar user, the risk is increasing. In particular, there is risk of not displaying and checking the depth accuracy, resulting in unpleasant situation for the passage planning those vessel to reach the depth limits, and finally to run aground because the depth result was not as accurate as the navigator to be expected. Here's the key issues of navigational waters. Shallow contour indicates the depth below a vessel could run aground, and it is equal to vessel maximum static draft. Safety depth is equal to maximum draft plus UKC plus squat minus height of tide. Safety contour is calculated same as per safety depth and activities alarm when depth is less. Depth contour indicates the limit of sea where shallow water effects occur that can affect a vessel. It should be estimated twice or 4 times the draught of vessel depending on the depth of water available. Here's the chart. water safe for navigation. We can see the rock formation, the white, gray, white, light blue, dark blue. Here's the safety depth, shallow contour, chart 0, safety contour, deep contour. ECDIS safe setting. Although color code may vary in different ECDIS systems display, the generic idea remains the same. Another key issue to consider is to conclude the chart depth accuracy into UKC calculation or make a comparison between the CATZOC with the UKC, which is more common. The UKC set the minimum of distance between the deepest point of a vessel and sea bottom. In particular, it is a company-specific measurement. Therefore, it is company responsibility to specify this distance in masters. And masters must consider it during passage planning. In conclusion, electronic charts and ECDIS are necessary tools for navigators in order to plan their routes and monitor the position easier and faster. Considering that these electronic means are based on human survey and measurements, the possibility of false information regarding depths, heights, etc. cannot be included. This is an additional factor to be considered during e-navigation, and therefore all mariners are advised to be always alerted and stay focused when they use this means of navigation. So this is this stress inside the our A1, which is triangle asterisk is at least greater than 1 with a depth of 10 meters, and our A2 is at least UKC 2 meters, and our B 2 meters, and our C with the 3 asterisks at least have 3 at least greater than 3 meters.